we have an easy question here on the topic of sliding window, and the topic is contains duplicates, the second version. The question: given an array, an integer array nums and an integer k, return true if there are two distinct indices I and j in the array such that the two numbers are equal and the difference, the absolute of the difference between the two indices is less than or equal to k. Alright, so what this question is trying to what this question means is, given an array of integers, we are supposed to find nearby duplicates within a certain range of like k. So given k, which is like the length of maybe a sub array, can we find two numbers within that sub array that are equal to each other? Yeah, that's what the question means. Then to solve this question, we will need there are a lot of techniques to solve this question, but the one that will give us the best efficiency will be the sliding window, because we are dealing with sub array problem, and also deals with like contiguous like elements. So we are going to consider like elements in a contiguous manner. So using the sliding window technique will give us the best efficiency to solve this question. To understand the question from the examples we are given, so right now we know that we are supposed to find nearby neighbors. So now let's try to visualize this this concept. Yeah, so taking the first example, we are given two numbers. We are given an array of numbers, and we are given a k value of 3. Then we are supposed to check and see if we could have like a sub array within this main array of length k, such that there are two numbers within that are equal to each other. So now let's see. When we take this first array, we could see that there are two numbers that are equal to each other. We have 1 and another one here. So 1 occurring at index 0, and you have another one occurring at the third index. So what we are going to do is we can use this one to compute the difference between those two indices. If the difference between those two indices is less than or equal to k, then we know we have a nearby neighbor. So now let's compute the difference. So when you have the first index, that's 0, when we subtract 3 from it, we are going to have -3. But then the question says we take the absolute of that will be 3. And since 3 is equal to the k value that we are given for this, then we know that we have a nearby neighbor. So now let's consider the next example. We have this array of numbers, and our k value is 1. So when we look over here, we could see that we have 3 ones in the array. But then when we take the first one, we see that we have 1 occurring at index 0, and we have 1 occurring at index 2. So when you find the difference between that, that's 0 minus 2. This is obviously -2, and it's not equal to our k value, so we'll disregard that. Then we'll proceed to the next set of equal values that we'll find. So over here we'll see the value occurring at index 2. The next one is occurring at index 2, then the minus, then the next value that is equal to that occurs at index 3. Then when we find the difference, this is going to give us -1, and if we take the absolute value of that, then we have 1. It means that we have a nearby neighbor, a nearby duplicate. Then when we consider this one, which is false, we are supposed to return false. When we see over here, our k value is 2, which means that we are supposed to find a sub array of like 2 elements of length 2. Then we are supposed to check if there are duplicates in there, two numbers that are the same. within that. So when we take this one, we can see one occurring at index 0 and one occurring at index 3. Index 3. When we find a difference, that will be negative 3 and it's not equal to 2. So we disregard that. We can see 2 over here and we have 2 over here. 2 occurring at index 1 and the next one occurring at 2, 3, 4 at index 4. When we find a difference, that's going to be 3. Still not equal to k, not less than or equal to k. So we disregard that. Then the next duplicate we find will be 3. 3 here and 3 here. So 3 occurring at index 2 and the last one occurring at index 3, 4, 5. Then we find a difference, we have 3. So over here we don't have a nearby duplicate. Now coming to the solution of the question. So first of all, we want to be able to keep track of the element that we find and also their indices. So when we take the first item, we'll log the element into the tracker that we have. In this case, because the dictionary have like a runtime for lookup and also insertion of like order of 1, I think that one will be like the best data structure we could use for tracking our indices. So first of all, let's have our tracker. So we have our tracker over here. So this is the dictionary we use to track the elements that we find in the array and also their indices. And the next thing we'll do is to iterate through the list that we have. So when we iterate through the list, iterating through the list. So now for each of the elements and their indices, if we find a number or an element that is already in a number tracker, it means that we have a duplicate. Then we also check the index. Is the index equal to the is the difference between the index, the current index that we are iterating through, and the index of the number found over here? The difference between those two indices, is it equal? Is it less than or equal to k? If it is, then we return k. We return true. So here is the check. So we check if the current number is found inside a numbers tracker, and that's not all. When we find a duplicate, that's not all. We also check if the difference between the current index that we are iterating and the index of the number in our numbers tracker dictionary is less than or equal to k. If this is true, then we return if I can spell it incorrectly, return true. Yes, but if we don't find, if we realize that we don't have the current index in a numbers tracker, what we can do is to put that number inside of the numbers tracker, and this is how we do it. So if you don't find, if this condition evaluates to false, either the number we don't find a number, or we find a number but the difference is not less than or equal to k, then we put the number in a numbers tracker with its index. Then if the loop should exit without ever evaluating this to true, then we return false. So this is basically our code. Now let's run it and see. Alright, I think we have indentation problem. So yeah, I think we are good. Still indentation problem. I guess we are good here. Or return. Let's run our code. Okay, so you can see all our code. Our code is passing all the test cases. Now let's submit to see if it actually passes the other test cases. Boom, we have our code running. and also passing all the tests, the runtime analysis of our solution. So what we see over here, we are iterating through a list. So the worst case scenario is that we go through each of the elements of the list. So over here, our runtime is going to be order of n. That's the number of elements in the array. Then when we come to the next line over here, we are kind of doing a dictionary lookup over here, a dictionary lookup, and we know that the lookup of a dictionary, the runtime of that is order of 1. That's it's kind of linear. No matter the number of items in the array, it doesn't affect the lookup. Then on this line 7, what we are doing is we are inserting an element into an array, and the insertion, the runtime of inserting an item into an array, into a dictionary, it's is order of 0, order of 1, sorry, order of 1, O of 1. Yeah, so in all, when we consider the worst case scenario, the runtime of our code is of order of n, O of n. Yeah.